Any other questions about this? Do you have any questions? All right. So, here's one thing I want to make you aware. Look up here. One thing here. I had a few questions during the break regarding this plus and minus situation with these alphas and betas. I will give you another homework, and you can try it at home and see if you are actually getting the right numbers. I mean, you need to convince yourself. I mean, I can explain it to you as much as I want, and you can probably memorize as much as you want. As long as you don't convince yourself, it doesn't make sense. Okay? So you need to do a few examples to understand which way I should go, which way I should take minus, which way I should take plus. The biggest thing here is that there's a difference between this angle definition and this one here. Because this one here is a positive YB would be like this, and here a positive ZB would be in the opposite direction. So just think of that. Okay. Another thing about side slip and angle of attack, that's kind of interesting one. You know, think of this airplane now like that. And let's say the atmosphere is still. Okay? Atmosphere is still with respect to Earth. So the airplane, let's say, has a certain velocity with respect to Earth. Looks like this. Okay? Now the airplane looks like it's going straight up, but that's fine. So this is the velocity of the airplane with respect to Earth. So I'm claiming, if that is true, then V infinity is in the same but in the opposite direction. Because V infinity is the air velocity that the airplane will see. Right? Let's make it another airplane. Let's look at it from the side. Let's say this is VE. Okay. This is the velocity of the airplane in the atmosphere. And this is the velocity of the airplane with respect to someone looking from the Earth. And the atmosphere is still, which means no wind. Okay, still atmosphere. No wind. So that means the air particles also move in this direction, but in the opposite way. Don't do it again, just run. Right? V infinity is in the opposite direction as VE. You understand that? The problem with coming late is that you are losing everybody loses concentration. That's the problem, including me. Okay? So the air particles seem to be moving towards the airplane with this velocity, and it is the same velocity but in the opposite direction. Is that okay? Good. So let's take another example. I'm trying to make a point. This is not let's say this is my airplane. And let's say this is V. And let's say this is V infinity because the atmosphere is still again. Okay? And this one here is X body. Do it like this. So, because the atmosphere is still, the velocity of the airplane is this one, and if the atmosphere is not moving with the Earth and the atmosphere is the same reference frame. Do you understand that? If the atmosphere and the Earth is not moving with respect to each other, then it is the same reference frame. Basically, someone looking from the air and someone looking from the ground will say the same thing because the Earth is not moving with respect to the atmosphere. Then it is the same reference frame. Understand that? Okay. So this is x body, this is v infinity, and this is going this way, and therefore all air particles are moving towards the air, towards this like that. Is that good? Okay. Now here's my claim. Where's the angle of attack here? Let's make it with another color here. This angle here, I will call angle of attack. In fact, it's a positive angle of attack, isn't it? Because v infinity is coming from the bottom and you have x body over here. Is that good? Okay. What's the angle of attack for this airplane? Angle of attack for this one is equal to 0 if this is exactly x body. If this is x body, then the angle of attack is equal to 0. Here x body is in this direction, therefore you have an alpha. Is that good? Understand? Okay. So, can you write VE in the body fixed coordinate system over here? There will be obviously a U for this one. What will it be in Y if beta is equal to 0? Let's say beta is equal to 0. What will be the Y direction? 0. How about the W direction? 0. It will be 0. There is no velocity in the body z direction. Z body is equal to 0, right? The whole velocity is here. And this is for alpha equals 0 and beta equals 0. For that case, we have this. Anything you don't understand here, please tell me now. Let's look at this one here. Let's say beta is equal to 0 again, so nothing is coming from the side. Try to write this one. What will it look like? V body E. There will be a certain U, right? In fact, it will be V cosine alpha, I believe. Is that right? V cosine alpha. How about Y? 0. How about W? V sine alpha. Will it be a minus or a plus? It will be a minus. Okay. Is that okay? Now here's what I claim. So this one here is U, this one here is V, and this one here is W, right? The body fixed velocities. So here's what I claim. Whenever alpha is not equal to 0, then W is also not equal to 0. I will even go further and say whenever alpha is equal to 0, then W will be equal to 0. Would these statements be correct? Looking at that picture, would these statements be correct for a still atmosphere? Would these statements be correct? Sorry? That airplane is flying with a velocity. Yeah. So is this correct? Why not? For beta equals still atmosphere and beta equals 0. So that's what these are the two conditions I impose. So it's a 2D problem. Are these two statements correct or not correct? Could there be a condition where W equal to 0, but alpha is not equal to 0? Or alpha equals 0, but there's a W? Could there be a condition like that? Are these two statements correct? How many people say yes? How many people say no? Looks like we have more yeses, right? So, why do you say no? Okay.
The infinity comes from the x side of the plane.
Yeah.
And it's phi. The angle is 180, but there is no velocity in that direction.
But will that be an angle of attack? If the V infinity comes from the back, what is angle of attack? No, that would be the side slip. The angle of attack is to rotate around side slip and this one here. Or in this case, actually, because this is the symmetric plane, it is already in the symmetric plane, so it will be 0. Alpha would be 0.
According to CL alpha graph, when we set the alpha equals 0, we still have a CL value. And we have also generate lift during alpha equals 0. But if we generate lift more than our weight, we have W components, or we cannot generate more than weight. We have also W components.
So you're saying, so you're saying if alpha is equal to 0, I can still generate lift. As a lift, if this is less than weight, then I will go up. Because I will go up, then I will have a W component. Look, for 0 alpha, I have a W component. Well, what you're telling me is what's going to happen in future. Momentarily, alpha is equal to 0 and W is equal to 0. Let's say for a moment you create more lift. So you will start going up, which means V infinity will also move. If you start going up, this is V infinity now. Isn't it? Yes or no? If an airplane moves up like this, where is V infinity? Is it still this? No, this is V infinity, right? As a result, you have an alpha now, which is actually negative. And because of this, because you're going up, you have a W. Right? So what you're describing is this. You start here, and let's say for some reason you get more lift, then you have this. Understood? Any other comments? Yes, please.
I think if the aircraft somehow can go this way,
Yes.
then there will be a Z component.
Yes. Yes.
The angle
The angle
of attack will be 0.
of attack will not be 0 if you go downwards like this, because V infinity will come from below. In fact, the angle of attack will be 90 degrees, because this is V infinity now. I think what you are getting always biased towards is that positive angle of attack is creating lift, therefore I need to go up. Or V infinity should always look like this. If I'm falling down, there cannot be a positive angle of attack. You know, you're getting all confused with those concepts. All these concepts are concepts in steady state for performance, simple aerodynamics, 2D pictures, and all this. V infinity, look up here, is the movement, let me just get up here, is the movement of the airplane, or V infinity is the velocity of the air particles with respect to this airplane. Okay? And I'm putting a simple arrow that represents the vector, the velocity, the relative velocity of the air particles towards this airplane. So if the airplane is doing this, these are the air particles that it will see. And what is the velocity of the airplane? The velocity vector will be like this, actually. It's falling down. So therefore, V infinity will be like that. What is W? Is there a W in this picture? Yes, the whole velocity is w. Okay? In case you wonder what u, v, and w is, these are the velocity components of the airplane in the body fixed coordinate system. These things you really need to understand. U, v, and w. Okay? So there's one vector of the airplane that this is the total velocity vector. You rewrite this velocity vector in the body fixed coordinate system, u, v, and w. So if the airplane is falling down, everything is w. Is there an alpha? Of course, that's alpha. Okay, it's a positive 90 degrees alpha. It's not a nice alpha, but there is. Okay? Any other questions? If the airplane goes up like this, where is v infinity? Here. That's v infinity, because you're going up like this. How big is alpha? Is there an alpha? No. I mean, if it's exactly along x body, there's no alpha. The airplane is going up, alpha is equal to 0, but it's going up. So now you have immediately in your mind, how is it going up if alpha is equal to 0? Well, maybe it is arranged such that it can do it. Or alpha is really tiny. Or the wings are attached a little bit with an angle and it can still go up. Okay? Doesn't matter how it goes up. If it goes up like that, and if this alpha is equal to 0, then alpha is equal to 0 and it goes up like this. Another question. Same picture. Just 1 second. The airplane is moving like that. Where is v infinity? Here. That's v infinity now. Is there a large alpha? Yes, it has a huge alpha. So if you see a picture like that, and I tell you what's the angle of attack, don't tell me this is angle of attack. The airplane might be going like that, alpha is 0, or the airplane might be going like this, then you have a lot of alpha. Question. If you're going up like this and alpha is equal to 0, is there a w component of the velocity vector? No, everything is going in that direction, there's no w component. You see? Do this. Lots of angle of attack. And this is your velocity vector now. Is there a w component? Yes, of course. This plus this, right? So, reduce the alpha. This is the velocity vector. Reduce the alpha. Is there a w? Yes. Now it's 0. Is there a w? No. So that's my point. If there is a w, there is an alpha. Okay? If the airplane has a w vector, there must be an alpha. If the atmosphere is still. The wind condition will come in a minute. Atmosphere is still. There's a w. There must be an angle of attack. If w is equal to 0, angle of attack is equal to 0. Understood? So there's a one-to-one relation between the w velocity of the airplane and the angle of attack in case the atmosphere is still. Okay? Any questions? All right. Does that make sense? So here's what I say. My conclusion to this. Alpha and w, this is the body component, this is the body velocity in the body z component, have a one-to-one relation when there is no wind. In fact, alpha is equal to 0 when w is equal to 0. And w is equal to 0 when alpha is equal to 0. So it's an if and only if situation. There's 0 if and only if the other one is 0. Alpha increases as w increases. And on top of this, you might want to say fact. Okay? It's a geometric fact. The way we define alpha and w. W, again, is the velocity component of the aircraft in the body z direction. And the velocity is with respect to Earth. And when I say still atmosphere, the reference frame of the Earth and the atmosphere is one and the same. And therefore, it is the velocity vector component of that, of the total velocity of the airplane with respect to Earth. Okay? So here's how we do this. We need to write a relationship now this is how we write it. If this is the airplane, X body, Z body. If this is V infinity, so then this would be the velocity vector of the aircraft. And I could write this like that. Let me write it with this. So this one would be W. This one would be U. Okay. And this angle here we call alpha. And therefore I could actually simply write, I could write this in a number of different ways, but I'm going to write it in the following way. I'm going to say tangent alpha is equal to U divided by, W divided by U. Right? That would be tangent alpha. So alpha, you could write tangent over minus 1 W divided by U. Okay? This is one definition that we like to have if you have still atmosphere and U is the velocity vector of the airplane and so on and so forth. Okay? And you will see this in many books. But you have to understand what it means. What is W, what is U? U and W are the velocity vectors, are the components in the body fixed coordinate system of the velocity vector of the airplane. Okay? And you get alpha. That is only true if the atmosphere doesn't move. If the atmosphere starts moving, which means there's a wind, U and W must include those components, those wind components. Because at the end, alpha is a function of V infinity. Has something to do with aerodynamics, with V infinity. So it doesn't really have anything to do with this velocity vector with respect to Earth. It has something to do with the velocity vector that is V infinity. And if there's wind, V infinity includes wind. Okay, I will talk about this in a minute. The wind condition, maybe in the next hour. Any questions here? Yes?
I'm just wondering, that's why I'm asking.
Yeah.
If we say we have the alpha is bigger than 90,
Yeah.
so it becomes like we have slightly the 180 degree, right?
Right.
So it becomes lower than 90.
Alpha being larger than 90, I will talk about the limits there. Okay, we will talk about the limits. But alpha bigger than 90 doesn't really make much sense in aerospace, right? I mean, you can then do two things. Either you rotate that by a beta and then come back with an alpha. You can do that. It would be still the same thing. I mean, although it doesn't make much sense, but you could do it. I mean, look up here. Airplane, V infinity like that, right? So you would be doing this, beta, and then moving down, this would be your alpha. So you could actually say that this is your alpha, but with a side slip of 180. Does that make sense? So the convention is pretty consistent. Doesn't matter where V infinity comes from. So this would mean that the airplane is doing this, right? Or the airplane is still and there's air blowing from the top. That's the same thing. Doesn't matter. The airplane doesn't care how the air particles reach this airplane. Either you move and the air particles hit you, or vice versa. I mean, at the end, the airplane, what it's trying to do is it takes the air particles, turns them around and moves them a little bit downwards. And this moving, you move it downwards, you blow the air somewhat downwards, you change its direction. If you change enough air particles downwards, you keep yourself up. It's conservation of momentum, right? So either you stay here and air is coming towards you and you take with the wings, you move the air downwards, or you just move towards the airplane and change the direction of those air particles and you keep yourself up. Right? It's the same thing. Any other questions? Okay. So the same argument is true for an airplane in side slip. Call this x body, and let's call this v infinity. Okay, and this is a positive side slip to the right. Okay, what we call a positive side slip. So if the atmosphere is still atmosphere, okay, so the air particles are here. That means the velocity of the airplane is in the same direction as v infinity, but in the opposite direction, of course. This is the velocity of the airplane with respect to someone looking from the ground, and since the atmosphere is still, it's the one and the same reference frame. Okay, so that's v infinity. So I'm claiming this guy here, this v infinity, the velocity of the airplane has now two components. One is this one, u, and one is this one, and this is v. And I'm claiming now, like I did before, beta is equal to 0 when v is equal to 0, and v is equal to 0 when beta is equal to 0. It's the same statement. Okay? Because if you take that airplane and say this is v infinity and this is x body, right, and this is y body, that means the airplane is moving with the same velocity towards v infinity, right? This is the velocity of the airplane. So it really means that there is no component on v. In fact, ve would be just some u, nothing to the side, and I don't know about the bottom, but let's say there's no angle of attack either, so it looks like this. So this is the velocity of the aircraft, and you don't have anything in the y direction if beta is equal to 0. If beta is not equal to 0, you would have something in v. Does that make sense? It's the same idea, the side velocity. So the way we are defining, the way we define this now is like this. As I said, the velocity of the airplane means that this is u and this is v. Okay, and this is v. And this is beta. So you could really write this. Sine beta is equal to v divided by that's the total v, the magnitude of the big V and therefore beta is equal to sine over minus 1 small v divided by the magnitude of the big V. Sorry, this is getting out of battery again. So we have one-to-one relation between beta and V, similar to the angle of attack situation. Is that okay? Okay, let me try to explain it here again with my little airplane. Let's look up here. Look up here. This is my airplane, all right? And let's say I have V infinity coming from here. What does it mean? The airplane, if the atmosphere is still, and this is V infinity, that means my velocity must be in that direction, isn't it? So I'm actually moving like that, a little bit to the side. Right? This is V infinity, and this is the velocity of the airplane. So the airplane is not moving straight, it's moving a little bit to the side. So it's doing this. It's moving straight towards you, of course, but at the same time, it is moving a little bit to the side as well. So the total movement of the airplane is something like this. It is flying what we call with a side slip. It's slipping to the side. I mean, that's what it means. You really want the airplane to go straight like this, but the airplane is slipping to the side, so it's moving forward, but a little bit to the side as well, which means your V infinity is in this direction, like this. And your velocity, therefore, is also in that direction. Okay? Take this picture, look up here, and rotate this picture. V infinity now like this, and the airplane is flying like this. Aerodynamically, it's the same thing. You could have an airplane that is flying like that, sideways, which means this is V infinity, okay? And this is beta, okay? And there's a side velocity, V, because you're flying like this, has a beta. This picture and that picture is the same, because in both cases, V infinity is coming from here. Okay? Understood that? So V infinity coming this way. You either move like that, or you rotate this picture, and you fly like that. Same thing. Both have side slip. Because if you see a picture like this of the airplane, you would expect the airplane to fly like this, but it doesn't. It flies like that. So if you see an airplane that looks like this, you would expect it to fly like this, but it flies a little bit with a side slip, so it goes to the side. Whenever it goes to the side a little bit, you have a side velocity from here, isn't it? I mean, the air velocity, but also the velocity of the airplane will have a velocity in this direction. Look up here, it's very obvious you're going a little bit to the side. With a side slip, you have a velocity, the V velocity is not zero. The V velocity is only zero if I just go straight like this, which means there's no side slip. Again, no wind. Okay? You understand that? Same thing like this. Your airplane flies like this. Do you have a side velocity, V? Yes, you have this V velocity because a little bit here, a little bit there. This is your velocity, so you have a V velocity. Whenever you are here, no beta anymore, the V velocity is gone, you see. So beta, the side slip, and the V velocity have a one-to-one relation, and this is how we represent it. Any questions? Okay, this is side slip and angle of attack. Now, here's the part where you might get a little confused now. What happens if we have wind? Okay, what happens if we have wind? So let's look at this. This is your airplane. And the airplane, let's say looking from this is the top view. So we are looking at this airplane from the top. Okay, so this is the ground, and you are here looking at the airplane and saying the airplane is moving in this direction with a certain velocity. The velocity of the airplane is, I don't know what it is, but this is the velocity vector of the airplane with respect to Earth, and this is you looking, I'm looking from the top, maybe you have a little head. That's your head. Okay, you're looking at this thing and you see this velocity vector. Now, if there is no wind, then this is V infinity, isn't it? This would be V infinity if there was no wind. Is that right? Okay. Let's just say there is air blowing from the side like this. There's a side wind. And let's say this wind velocity is, I don't know, I'm just making this up, VWW. Okay? Let's say this is the wind velocity. Now, let's make it something totally different. Let's make it a big W, okay? So you have a wind velocity coming from the side, it's a big wind W, and this is the velocity vector of the airplane with respect to an observer on the ground. So the atmosphere is not still, the atmosphere has this velocity everywhere. So, and the velocity of the airplane is this one. Good. What is V infinity? Can you plot V infinity? V infinity is the velocity of the air particles that moves towards the airplane, isn't it? Good. So the airplanes, the air particles move in two ways. They move because I'm going towards them, so it's this one here. Plus the air particles are moving from the side, so it's this one plus this one will be my V infinity. Understand? So I have two things. One is because this one here, it's this VE, the magnitude of the VE, it's this one, right? Because I'm moving towards the air particles, but the air particles are moving also in this direction because of the wind, right? The blue one. And V infinity will be that. That will be V infinity. This is the wind, okay? And this one here is minus VE. This one here is minus VE. This one here is the wind. You add them together, this is V infinity. These are the air particles that the airplane will see. So if you draw a clean picture, the airplane looks like this. But the airplane is actually moving straight forward. This is the airplane's movement with respect to Earth. You look at the airplane, it's going straight. But V infinity is coming from the side because you have the side wind. Does it make sense? So if there was no side wind, V infinity would have been the same but in the opposite direction of VE. So the airplane is flying straight forward. Does it have a side slip? Of course it does. That is your side slip. It's a negative side slip, of course. So, what is the situation here? Sorry. What is the situation? The situation is like this. Look up here. This is my airplane. Air is blowing from here. Okay? And my airplane is flying straight. What do you see? The airplane is flying straight? Yes. Does it have a side slip? Yes, because of the wind. If there was no wind, would have been a side slip? No. But now that we have wind from this side, V infinity is not straight, but it's coming from an angle. So it is flying straight, but with a side slip actually. Remove the wind, aerodynamically, it is the same thing as the following. Look up here. Side wind, flying forward, This is V infinity, and therefore this is beta now. The airplane is flying forward with respect to u, but V infinity is coming from here because of the wind. Right? Does it have a side slip? Yes. How would I remove the side slip for this airplane? I would rotate it like that, 0 side slip, and fly like this. And this is still the same velocity, let's say. If you look at this thing, the airplane flies like that. Does it have a side slip? With the wind. Does it have a side slip with the wind? It doesn't have a side slip. Because this was V infinity. Remember, this is V infinity. You see that? Set it back there. This is V infinity. The airplane is flying straight. Air is blowing from this way. V infinity is no more here. V infinity is here because of the wind. Okay? If I rotate this airplane now, it's flying this way. But this is V infinity. Do I have a side slip? Side slip we defined by now very precisely. It is xw, the wind x fixed coordinate system, to the body fixed coordinate system. The body fixed coordinate system you see. xw is here. Is there a side slip? No. The airplane is moving this way with 0 side slip because there is wind. Is it confusing or does it make sense? Again, no wind, going straight. V infinity here. Suddenly there's wind coming from the side. V infinity rotated because V infinity represents the movement of the air particles. So V infinity is here now. Okay? So you're going like that. If you remove this, anyone looking from the ground will say it's going straight, and V infinity, there's no side slip. But because of the wind, there is side slip. Aerodynamically, there's a side slip. So if I rotate my nose towards V infinity, and I fly like that, do I have side slip? No, because of the wind. Looking from the ground, you might think it is in side slip. But V infinity is actually blowing towards the nose. Okay? And therefore, my side slip is 0. But it flies like that with the wind. Understood? Does it make sense? So let's give a break, and you think about it during the break. Yeah, I mean, this is aerospace. And nothing is very straightforward. And you're lucky that it's not straightforward. Because if it was straightforward and everybody can do it, you would not have a job. Somebody will pay you if it is difficult and nobody else can do it and you understand it. Okay? So let's give a break.